Yeah, thanks you for coming here, for the opportunity to talk here, and for the introduction. I'll talk about 4 things. I start with the quota system because we have seen unfortunate overload in the last weeks, and so I put this into the talk on last minute. I'll, for that reason, have a rather short section about the considered features, which means they just unfortunately got prioritized down. And then we'll afterwards rather talk about housekeeping, because in the meantime the file sizes have been grown, and a couple of people out beside me had been rightfully complaining about that the files are so big. And finally, this is how interaction works. I had been on asking people, I have heard back that a good thing would be if the overpass adheres to redacted information. And so I'm preparing that the overpass will in future video versions adhere to redactions in a way as decent as possible. So let's start with the quota system. What we have on usage is, this is the use of CPU. What happened is, What happened here is in February 2023, the Foskis gratefully sponsored a bigger server, and about a year of us, it was a luxury because the server had a lot more capacity. I think it's about the 1,200 that's comfortable. So we had 2 very nice years where the Foskis servers were just starting to be used. And then something has happened. I haven't completely understood it, but that's basically that's the background story of what happened and what makes the trouble. That something that's not obvious is using the service and a lot more in particular over the last year. It's not requests per se. We see that the requests, I've scaled the requests in a way that they could fit in a useful way into the diagram. And it's not the requests itself, because they are rather going down. So it's something running a lot of mid-sized requests. And what we also see is part of the problem, or part of the mechanism we see is that someone is going around who has really a large reservoir of IP addresses. Historically, I have used IP addresses as a scarce resource. I have to somehow sort out who gets how much computation time when there's high load. And the idea was to distribute it along IP addresses, because it would be hard for people to organize more IP addresses. But apparently something happened here, where this got totally out of control. And the essential part of the story is that we're nowadays, I don't know if do I have it on the, no, apparently not. What happened is that so far we have seen about 90,000 IP addresses which are genuine in a sense. It's about here, a little bit more here, but which basically, if you look after, come from all over the world, from consumer networks and some from servers. But we are now seeing at the side of these about 90,000, we are seeing 180,000, which whenever you look into, come either from AWS or from Azure. There must be something in AWS or Azure that it's easy to access services with a ton of IP addresses. And if you have the IP address approach, then apparently 2/3 will go that way towards AWS and Azure users, which is unfair to the people who sit behind ordinary computers. In particular, even more unfair towards people who have one way or the other mobile connections, because usually the mobile providers are quite short on IP addresses. For reasons that are out of my control, but that's one more reason to leave IP addresses, is that you quite often see over these mobile networks that they still do some large carrier-grade NAT and send people through IPv4. Also, everything should be IPv6 ready, and we shouldn't have seen that problem, but you definitely see that, and then it's extremely difficult. Those people where multiple people share an IP address tell apart from those people where Azure and AWS have just tons of IPv4 addresses. So that's basically the background story. why I'm getting away from the IP addresses. There's also some considerations in the background which had contributed to the problem. I wanted to feature augmented diffs and other cool stuff, and many of these is in the mid-range of size. So to ensure that augmented diffs go always through, I would be biased towards let queries that take some seconds, not much faster, not much slower, should be rather preferred over the other classes, which is now a disadvantage because we see the unwanted users in this class. Users are basically do not necessarily accepted in a certain number, but it's a little bit, we have heard for OSM.org a little bit the complaint that that OSM.org is not the world's free tile provider. And if you see that an app, that's a user agent IC, that an app is basically using this most likely to show to a lot of drivers the speed limit, which is an interesting thing to do with OSM data. But it's definitely not what Overpass is designed for, and where it's fair to get other people's scarce of resources for this. And same thing, this look about the details, just contemplate the details for that. Note natural water. I haven't looked up, but I suppose there are not that much legged objects with this. And there's a lot more behind this, and in fact I don't know the exact query because I log only an upper limit of 8 kilobyte per query, and afterwards it just ends in ... because I don't want to get the service down by getting the hard disk full of log files. And so it looks extremely like cheaters of Pokemon Go, because they are seeking in a clumsy way about water-related features. And so this is why the basic problem that I'm now the first time faced to be that I should ensure that I'm not the world's free CPU time provider. And first question, could we just easily solve it by IP addresses? And I might be particularly clumsy, but I wouldn't be too surprised if other people who have experienced it would confirm that it's quite difficult to just tell apart AWS and Azure. You would have to maintain long lists of who are the bad guys, who are the good guys. There are even some legged cases where you just have caching going through AWS and Azure. So you can't just say we throw out entire networks. But you see some peaks, but it's not that you have a clear antagonist here you should fight down. It's a mixed thing. It would be a lot of invest of a lot of manual labor to get this under control. So to spread it out, this is where I suppose I'm seeing Pokemon Go cheaters, and you see it's extremely correlated with these a lot more IP addresses. So I suppose really that's what's going on. Also, I'm not entirely sure. So basically what I'm going to do is to move forward in the sense that there should be in a couple of weeks a fast lane for people who send a token that's related to an OSM user account. The basic idea is just run an OR2 service that will require an OSM authentication and then spit out a token, which is basically a large random number. And then have a database where I have all the valid random numbers, and then we'll just look up when someone sends a token, whether it's a valid or no token. So no high tech in the background, but would, in case there's heavy overuse, enable me to track back who's really behind the usage. And the hope is, I'd also consider to use user agents, but in principle, with the OSM account, everything I need is possible. In particular, with redactions in mind, where I definitely want to go towards a place where some data is only available to people where it's reasonable that they have an OSM account. It's definitely a good thing to do, whereas user agents will mean I'm mostly playing a whack-a-mole thing, or again getting into a situation where I have to invest a lot of manual labor to get the quota system working. So let's get to the a little bit nicer things. The considered features. The augmentatives are in fact relatively little used. I was surprised. It's not that there are a lot of people running around, and even advertising them and talking about them did not make people use them on the public instances. I have some indications that there are other instances that use it, or, I mean, if you think of OSM cars, they used it for many years, and now they had time to use instead something that's optimized. And what's much more in use is Akavi, which I'm grateful to Norbert Renner, who's also not here, who has implemented it, and which is quite useful to look into what changes are actually doing. And there had been, as mentioned, in June 2024, there had been a large vandalism wave where I have asked whether there would be a demand for a heavy undo tool where you just say, this is a strange user, just start out the robots and kill everything that's related to this user in one go. And the answer back was it was rather more useful to have proper redaction in Overpass. So this is, I've discarded that idea and rather care for this. And the other thing that's frequently asked for are, isn't there a feature that I could just get all deleted objects in a bounding box? The problem with this, it's not so much the technical side. The problem is that it's a service that will deceive users. It's absolutely guaranteed that a lot of users will be deceived because the data they are searched on had instead been moved or split or retagged or moved, deleted or repurposed. We have seen a lot of this. We have even seen in the every door where you could update tags, which is in principle a good thing. But this means that in a lot of cases when you say, oh, I would like to see whether there had been a restaurant, if the restaurant had been just rectified to fast food, it would be technically just changing a tag and it would not be a deleted object. So as it is basically impossible to have a useful user interface that's anywhere near self-explanatory, I decided rather to offer a feature that I would, or rather to plan with a feature that I would call tag timeline, where you could say, I've just taken a change that I've made myself, where I figured out that what used to be an ice cream parlor is now an Indian restaurant. And so what you could do is, if you get to this bounding box, which you unfortunately cannot see, it's somewhere in Düsseldorf, and you wonder, hasn't there been an ice cream parlor in this near this railway station, which is unfortunately not visible here? And then you could just go to the bounding box and ask for, give me this timeline tag cuisine ice cream for this bounding box. And then it would spit out something along these lines where you would have, where you would see dates and related objects that existed, and then could, with the dates, actually look what the data looked been at that date or at that date, and then have actually a useful insight what's happened to the objects I had been interested in the bounded box, whether they ever existed. This solves along this in an elegant way. Also would solve also the to track split objects, because you would just see where the original tag come from. If you say, I'm interested where this highway got its secondary from, then you could just look up when the first object with secondary popped up there. So let's come to the next point, the housekeeping of to get the file sizes down. The background story is that we have seen a lot more OSM data. I think it was Jochen who has it in the talk. That with a positive side effect that you see a lot more data over the world. It's also a resource thing that basically both the planet of recent data and the history files have grown sixfold. And that means that you have a massive database of if you materialize an Overpass database. This is the size of the clone snapshot of the 8th of November. And if you start applying updates and with the usual head weight you need, you rather arrive at 100 and over almost a terabyte of data you need to run the worldwide database. There had been clear feedback from the lone wolf who had tried to run a backup that it's really a pain in the ass to do this. And you have to keep in mind you are just doing it 3 times, or depending what you do, even more So you are moving around hundreds of gigabytes 3 times. And even if you have hard disks aren't as fast as you think if you're really copying big files. So you are easily ending up that you have 2-digit hour sizes to keep this thing running. So the idea to keep the file sizes down is other part of the problem is that cloning gets so slow you can't have a clone file every 24 hours. Now only twice a week that I do it. And the first thing is to look into the data sizes, where it comes from. And what you see is where you could get into. This is a large thing. And basically, if you look into this, what it is, it's basically because we have the luxury of having an ID for every node. That's basically what makes this whole thing big. You have most nodes are untagged and are in fact serve only to have a coordinate for a way. And basically, if you get rid of the IDs, you could basically get this in theory get this down to 0. In fact, you would like to keep some for tagged nodes, so you're probably going to chop off 80% if you can. And the good thing is, if you are clever enough, most likely I can do this. I haven't implemented it, but I've rather started with a different thing, this user data thing. And we can again observe that most changes touch more than a node in a bounding box, or internally what I have is a tile to store data. And so you can dramatically shrink this one. And the other thing is speed up data is basically what with a relational database background, you can basically think of this as an index. It's just extra file I take to make some things fast that you want to see. And of course, you don't need it doing cloning. You could, if the transmission of the data is a problem, you could just transmit this, make backups of this, and then just tell the database before you start it up, it should recreate the indices, and then you have to deal with a lot less data. And that's basically what's implemented, although that's not published as a new version. If we compress the ID and user data, then we could get down from, the point when implemented in February, it was 630 for the snapshot, down to 544. And if you even throw away part of the index files, I have not thrown away all, you could get down to a little bit under 500. And I'm confident with the numbers you have seen here that you in fact could get down to 300 even if you have full history data. If we use every optimization that's with this background within tight, but implemented is to get down from the 650 or so to 450, which should be already a certain relief. So let's get to the final point, the adherence with redaction. We first should keep a short reminder on what redacted data is. We have usually we would find if we start peer review, that means a second mapper is looking at the same data. Usually the outcome will be it's confirmed, because a lot of the OSM data is good, it's quite long-lived, no problem here. Some other things are controversial, then they get altered, which means sometimes you talk of deleted, but in all these cases it means you don't see them in the current data or in a different way in the current data, but they are in principle still present if you do the right thing and ask for the old data with an old version number or with the date in Overpass. And by contrast, you have data you actually don't want to have anymore in the database. Basically, what you can think of, we have seen slur. We have in another talk the Jutopolis incident had been mentioned, but there had also been someone who had renamed Berlin to somebody else's passwords, not Andy's password, but somebody else's password, and. But essentially, it's vandalism for one part. But we have to redact this because we don't want to publish over and over again somebody else's passwords. We have seen data breaches where there had been rumors that there had been data breaches where we should have removed privacy data in a large scale that we should get out of the database. I don't think we have found it, so I'm not sure whether it's really actually had been there. But obviously, even if it's possible then. And finally, infringement of copyright. So that's the reason why you want to remove some data. And there are some problems. It's not visible through the main API, but copies may exist elsewhere, in particular unwanted copies, like in the case where Mapbox catched the Jutopolis. So we cannot make a sincere promise that we can clear that data from the internet. It's just we could clear it from our databases. And the other thing is if we are able to not claim something had been in the database, this implies that we are also unable to claim it had not been in the database. It's not true if we, in principle, could produce the data, could produce to a court the data that what actually had ever been in the database. But in principle, to an outsider who haven't access to the database itself, we couldn't prove that that slur or that copyright infringement never had been in the database, because it may have been. So we don't want to spread slurs, so we have to find some solution. Part of it is to be clear about the best efforts, that we are not the heroes of the internet to clear everything. And the other part is to implement it on a strategic level. We will declare all ethic art and non-public. It's anyway happening with the GDPR. The other thing is, so we need no unredact feature, because if it's anyway project internal and something has been flagged as inappropriate to be accessible, then there's no scenario where we would want to reverse it. Then tactically we will only withhold the output. We will not do it considered within the computation, because there are few but some elements which are inconsistent, but we have a relation where the members had been redacted. And this had been happened in 2012. So, but I'm pretty sure I haven't found any technical barrier in the source code. So I believe that it's more like because decent people use a redaction tool and not because it's technically assured, that we have seen no further relation where the members had been redacted and the relation hasn't. So the software must be technically prepared to not crash if it runs into something like this. And also, final thing, let only OSM users, if anybody, access the redacted data. We might even decide to restrict it and that nobody could ever access the redacted data except somebody with physical access to the hard disk. And so I will flag redacted element versions in the database by looking into full history file and then just flagging all the versions that are not present in a history file as being redacted at that point. That's just a haphazard first attempt to make this possible. If it's going to work, we probably could look into whether it makes sense to have a redaction feed. Whether it's a good idea or not is also an open question, because I don't want to expose the foundation to a Streisand effect. But in principle, we now get into a region where it's feasible to mirror redactions in a copy database like Overpass. Thank you for your attention. I'm sorry for being over time.
The full history planet files published on planet.osm.org obviously don't contain any redacted elements. How long does it take to do a full re-import from one of those? Because that would prevent you from even having them in the database.
I have to figure out. I think it's probably in the range of 2 to 3 days. I've never tried it. There are some optimizations that work against this, so I would have to figure out. It's probably in the range of many days at the moment.
If you did it, it would get most of the data out right away.
Yeah, that's and it's true, but I don't know what happens if I really run into a proper inconsistency. I haven't checked whether the history file has fixed this 2012 incident. Okay, thank you. Then I would look into that route.
Okay, next question.
Okay, so what is the reason of getting gateway times out in Overpass queries? And how can I prevent getting gateway timeouts in Overpass because it is frequently failing our daily pipelines to update our data?
The best way would be to run your own instance because then you have control about resource usage. It's basically what I have talked about, the quotas. It's the underlying reason of the gateway timeout is that there's not enough resources for all. And I'm trying to fix this by let proper OSM users identify in the long term with the tokens that they get from the user ID. Because then I could fast track them and ensure that proper users actually get access to the data, and we see less use for Pokemon Go cheaters and others tangentially unwanted users. So I'm sorry for the moment it's not possible, but it's actually why I'm working on getting this fixed and getting a system for prioritizing users that's completely independent of IP addresses.
Is that everyone? Yeah.
Would the solution also work with JOSIM? Like we use a lot actually Overpass in JOSIM, and would this authentication also directly work in JOSIM without configuration anything? Or would there be even an option to say, okay, there's actually a JOSIM user that's actually contributing data back? So would this be an option?
I suppose it will be for some time that I'm pretty sure the JOSM is under active development and the people are quite clever. So I think in the long term, like half a year or so, there probably will be a more convenient solution. But when we start this, what you will have to do is you will open this download window where you have the query, and then you would where you otherwise might put the thing like out JSON or something. You would then just say something like user : and then you have a token, and that token is most likely stable over indefinite time, definitely stable over many days.
Okay, well, thank you very much. That's super.